types of spacecraft it currently employs, which range from flyby spacecraft like the Mariner and New Horizons probes to observatory spacecraft like the Hubble and James Webb Space Telescopes. Essentially, anything that goes up into space can count as a spacecraft, even if its sole purpose is to remain in orbit only and study distant objects. We're always developing new ways to explore the solar system and the universe, whether that's by iterating on existing types of vehicle or by devising totally new ones. And science fiction has created plenty of lofty goals for NASA's real-life engineers to aim for, suggesting fictional spaceships we could use to travel the stars. Just how possible are these ships of the future, though? And what space solutions are the world's space agencies currently looking into? One of the main futuristic types of ship on the horizon is one that's powered by ion propulsion. This is a method of propulsion using an ion thruster, in which thrust is generated through electricity by accelerating ions. An ion is simply an atom with more electrons than protons, giving it a negative overall charge. The great thing about ion engines is that they already exist and have been used by NASA for years. The Deep Space One probe, launched in 1998, and the Dawn probe, launched in 2007, both had ion thrusters. So too did the more recent Double Asteroid Redirection Test, or DART, which featured NASA's Evolutionary Xenon Thruster, otherwise known as NEXT. Eon thrusters are a clean, efficient way to fly a spacecraft and can operate using locally generated electricity, whether that's from solar panels or other methods. Astronauts aboard an ion-powered ship could even generate electricity themselves through exercise equipment, as they'll need to exercise during long space missions regardless. The downside to ion thrusters is that they're very weak, so weak in fact that they can't really generate any meaningful thrust within Earth's atmosphere. And while they can produce travel that's very quick, they can also take a while to reach those high speeds. This means that while ion thrusters are suited for long journeys, they need to be combined with other, potentially less clean methods of propulsion to leave Earth's atmosphere in the first place, or indeed the atmosphere of any other planet. So currently, they're only really used on small objects like probes, and only once those probes are in space, after an initial launch using a traditional rocket. But there's another, far more fantastical propulsion solution that's perhaps just around the corner. It's one that doesn't exist yet, although it theoretically could. Warp drives. Einstein's field equations seem to allow for the existence of warp drives, much like wormholes. However, for a long time it was thought that actually building one might be impossible. A warp drive would require a monumental fuel source, and it was thought that only exotic matter would fit the bill. Suffice it to say, we haven't yet discovered the exotic matter that could do the job. But then, in recent years, scientists have put forward new research suggesting that actually there is a way to build a warp drive without exotic matter. This has blown all previous warp drive ideas, including the Alcubierre drive, out of the water, with some believing that a new design could feasibly exist today. There are still some challenges to overcome. First, the power demand for such an engine would still be monumental, and you'd run into issues for how to consistently generate so much power. What we perhaps need then are further advances in nuclear fusion technology. And fortunately, we now have them. In nuclear fusion, two atomic nuclei are combined into one. It's the way in which stars generate so much energy, and is the opposite of nuclear fission, which is how traditional nuclear reactors work. For a long time, the most promising means of achieving nuclear fusion on Earth has been through tokamaks, devices that use magnetic fields to keep plasma stable while it's heated to extreme temperatures. However, to date, tokamaks have not yet reached the condition of break-even, the point at which they produce as much energy as the amount put into them. A different kind of fusion reactor, however, has met and surpassed this condition: the laser-based National Ignition Facility in Livermore, California. On December 5, 2022, an experiment saw it generate more power output than input. Still, this technology is a long way off from actual use in spacecraft, but it could one day be used for warp drives. There are yet more problems to overcome, of course, including that a warp drive probably wouldn't be especially precise. Since it would be able to exceed superluminal speeds without violating the laws of physics, it would also be extremely easy to over or undershoot your destination when using one, and potentially by huge distances. Because of this, Computing also needs to develop significantly until we can truly put warp drives into practice. But what about even stranger spacecraft than that? Machines that many people already claim exist and even say they've encountered, but which science is still at a loss to explain? For decades, people have been seeing strange objects in the skies, often in the form of flying saucers. These are the quintessential UFO, the most recognizable alien spacecraft there is. But how might a flying saucer work, and are humans close to building one? Fascinatingly, as weird as they are, there are many engineers who have been trying to create one over the years and decades, including some employed at NASA. In fact, NASA has created a saucer-looking device called the Low Density Supersonic Decelerator, a flight vehicle that should help us explore and navigate Mars in the near future. It was first tested in the mid-2010s, and although it looks pretty alien, the LDSD is designed to make re-entry into the Martian atmosphere simpler and safer. Theoretical flying saucer designs have also been suggested as a useful tool in lunar exploration. With NASA heading back to the moon in the 2020s, scientists from MIT believe that a flying saucer using a small ion engine could be useful in traversing this off-Earth destination. Because of the moon's much lower gravity, a light enough object could be lifted into the air by an ion drive. And floating over the moon's many craters might be quicker and easier than driving rovers over it. The highly mobile, saucer-shaped UFOs of science fiction, however, still remain beyond the realm of possibility. We don't have a way to create vertical propulsion quite like that. However, we don't necessarily need a high-tech propulsion system to see the stars. There are ways around this, and if we were willing, we could send large numbers of humans into space very soon. The problem is that many of them wouldn't ever make a return journey. We're talking here about generation ships, another solution to the huge distances of outer space. Instead of trying to find a way around those distances, humans on generation ships would simply have to grin and bear them. They'd have to willingly sign up to the prospect of traveling aboard a spaceship for literally the rest of their lives. If they were to have children, then those children might live their entire lives there too. Traveling in this way, it could take centuries or even millennia to get to even nearby exoplanets. But crucially, and perhaps more than any other option, this one is at least possible. It would require better defense against radiation and large enough ships that people didn't get claustrophobic, not to mention a way to locally produce food. But it wouldn't require anything beyond the realms of physics. In the minds of some, these are all things that we could accomplish very quickly if we needed to. And if anything were to happen to Earth, sending people off on ships like this might just be the best way to keep our species safe and well. Finally, the other type of generation ship would be one that, like our other craft, is currently out of reach. If we added some sort of stasis system, such as cryosleep, then people wouldn't have to live and die for years on an enclosed ship. They could simply wake up when they arrive at their destination. Currently, however, although there's research being done into cryogenics, we're far from having a way to wake a human up after being artificially frozen. So this one's another for the future, even if that future is still a long, long way off. In general, as we develop as a species, we're going to need to keep inventing and creating bigger, better, and more exciting ships to take us to the stars. One day, it might even be a necessity to escape this world and venture out into the cosmos. Will we be ready? The plans, at least, are in place, because those are some of the different types of spacecraft